This here is our 1853 pump house. This used to house a beam engine, but now houses a gas engine, and we'll talk more when we're inside and out of the rain. Welcome inside. Welcome to the 1914 gas engine. This engine, like I said, was made in 1914 by Richard Hornsby and Sons. Richard Hornsby and Sons were a manufacturer of engines and industrial equipment until they merged with a company called Ruston's in the 1930s. This engine is a twin-cylinder engine. That means it's got a cylinder here and a cylinder on the other side of the flywheel, which you'll see shortly. So now I'm going to give you a close look at the engine and a bit more history about it. This here is what I call the driving deck. This is where we have all the controls to power the gas engine. So here we have the two cylinder heads. Now we don't run it on both cylinders anymore, we only run it on that cylinder. However, we use compressed air to start it on this cylinder. So we have a little valve down there which we feed compressed air into this cylinder, which gets the engine turning. Then when the engine is turning, we then put the gas and air mixture into this cylinder, it sparks, ignites and powers the engine. So this control here controls the airflow to the engine, and this control here controls the gas flow to the engine. And then in each cylinder there's this. This here is the spark plug, which is in there. You can see where it is there, that's the spark plug, and that ignites the gas and air mixture. Because believe it or not, gas on its own is not flammable. It needs air as well to combust. So this here is the main valve gear. So what you have here are individual valves. This one here powers the flicker, which flicks the magneto, which flicks the spark plug. This cam here operates one of the main exhaust valves, and then it also operates this main inlet valve. This down here is the air compressor. We turn it on and it pumps air into a cylinder, which then builds up pressure, which then it gets fed to the engine to power it for startup. And of course, like a lot of internal combustion engines, it is water cooled, so each cylinder has an individual water cooling system. Over here we have a barring system, so you have a bar which is slotted into that gap there, which looks like this. So you slot it in there and turn the engine over by hand. I'm not going to do that because we've been doing maintenance and we don't want to move it just yet. But later on in the video you are going to see how we run it and what goes into making it go. In this room here, next to the gas engine, which is just through there, this is the original gas producer. So what you have, this burns coke, and coke was used to burn air, and those are the chemicals to make gas. And the gas is then fed by pipes into the gas engine, which then made it go. So what you have, this is the main producer. So here you can check how your coke was burning. You actually fed it from the top. There's a little hole at the top where you feed the coke in. You then see over here, this is where the coke particles move over here into the baffle box. The gas moves on this way and the particles come down here. Any hot dirty gas comes down here to get redone, and then it goes into the wet coke scrubber, which is that part over there, to get cleaned and purified, ready to go into the gas engine. It then goes into the mineral wool scrubber to give it an extra clean, and goes through the very clean gas pipe into the reservoir, where it then gets fed into the gas engine system. This here is a small R. Hornsby and Sons engine, but this is a petrol engine, so you have a petrol tank in that tank there, which feeds into the engine. What this was used to pump air into the big cylinder next to the camera, and then that fed to the gas engine to start it. So this is an air compressor, and then when the engine was running, it then powered this Westinghouse dynamo via line shafting. But this dynamo could also be powered by the gas engine pumps via another line shaft. This engine is abandoned until around 2017 when we got it running, and now you can see it run on our open days. And you can see a few clips of it running on your screen now.
Normally it's up to about 100 volts, so I don't sorry that.
So the engine, this little engine is very much like its big sister, the gas engine. You have the main magneto here, which is operated off a cam, which sparks the spark plug. This is the main fuel control, so that's going to shut. We can open it to how much we want. This is the air pump, So this one's a single cylinder and it's hand started. You have to crack this one over by hand.
Go on your pocket, James.
Yep.
Keep going. There we are. I just put my finger over here.
But it is also water cooled, just like the main gas engine. This here is the twin set of gas engine pumps. Behind me we have the river pump, and next to me we have the town pumps. These are powered by a belt which runs from the gas engine over there through that big wheel, which then powers a clutch, which is controlled by these wheels, which then individually powers the twin set of triple ram pumps. This here is the old belt, and one time I was running, that happened. So we've got a nice, lovely new belt on the gas engine. And we take these off to dry, but over here we have the main river gauges. So you've got town suction, town discharge, river suction, river discharge. So 2 gauges for each set of pumps. One important thing to note about our gas engine is that it is unique. It is the biggest gas engine of its type left running in Europe, if not the world. There is a single cylinder version of our engine at the Anson Engine Museum. That's only 150 horsepower, ours is 220, and theirs doesn't run at the moment, but they are restoring it to run, and we wish them all the best. We can access the pumps by this spiral staircase, which I will show you now.
that to there. Right. And then while this is still going, you take the pin from there and slide that over.
Had enough?